Okay, so in this video I'm going to have a look at a particular question that came up in the 2014 higher level paper on sequences and series. So the first part of the question involved a Tn is equal to log a to the power of n, where a is positive and a is also a constant. And the first part of the question asked us simply to prove that terms 1, 2 and 3 are in arithmetic sequence. So term 1 is just simply log a to the power of 1, term 2 is log a to the power of 2, and term 3 is log a to the power of 3. So are these three in arithmetic sequence? Well, to do that you just simply do t2 minus t1, and that will give us log a squared minus log a. That's just simply log a squared over a using the laws of logs, and using the laws of indices, subtract the indices, you get log a. Now we also got to do t3 minus t2. That will give me log a cubed minus log a squared. So that's just simply log a cubed over a squared. So that again is subtracting the indices, log a. So in both cases we get log a. Remember, a is a constant, so the log of a is also a constant. So therefore the first three terms are in arithmetic sequence. Now the second part of this question asks us to prove that the sequence is arithmetic and find the common difference as well. So Tn is equal to log a to the power of n. So to prove that this generally is arithmetic, so again we do Tn minus Tn minus 1. So you subtract any term from the next term in the sequence and we should get a constant. So we're doing this algebraically rather than sticking in numbers into our formula here. So this will give us Tn, which is log a to the power of n. We want to subtract Tn minus 1, so that's going to be log a to the power of n minus 1. Now if you do that again, that's going to be just simply log a to the power of n over a to the power of n minus 1 using the laws of logs. Subtract our powers there, so you get log a to the power of n minus 1. Again, put this in brackets because you've got a minus here. That gives us log a to the power of n minus n plus 1, and that just gives me log a. And that's going to be d, our common difference. Log a is a constant, so therefore when we subtract any term from the following term in the sequence, we get a constant. A is a constant, so log a is a constant. And that's d, our common difference. Now, the third part of this question is 1, 2, 3 here. So the third part of this question is an equation. So we've got t1 plus t2 plus t3 plus all the way up to t100, and that's going to be equal to 10,100. The question asks us to find what value of a will give us this equation, will work for this equation. We know that term 1 is log a, term 2 here is just simply log a to the power of 2, term 3 is log a to the power of 3, and so on up to log a to the power of 100, and that gives us 10,100. So what value of a is going to work here? What value of a will we have to stick in here, 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 and here, and so on, that will give us 10,100? Well, on the left hand side we've got the sum of the first 100 terms. So we know from our previous videos that Sn is going to be n over 2 times 2a plus n minus 1 times d. This is our general formula to add up n terms in a sequence. So in a series rather. So we want, on the left hand side we want S100. We're adding up the first 100 terms. So that's going to be 100 over 2 times twice the first term, which is log a, plus n minus 1, it's 100 minus 1, which is 99, times d, which is log a. We had this in our previous section, and that's going to be equal to 10,100. So this gives us 50 times 2 log a plus 99 log a is 101 log a. On the right hand side we have 10100. So let's do that then. On the left hand side here we've got 50 times 101 is 5050 log A, and that's 10100. Divide both sides by this and you'll get log A is equal to 2. Now remember, ln of A is just simply log to the base E of A. It's just a different way of writing it. So in other words, we have an E down here, so E to the power of 2 should give us A, changing it from log form to index form. So let's do that then. E to the power of 2, if you do that on your calculator, you should get A here should be equal to 7.389. In other words, if you put 7.389 in here, 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 and so on, all the way up along, and do all the logs, you will get 10,100. Okay, so that's the third part of our question. So let's look at the fourth part of the question then. So fourth part is to verify a particular equation is true. So what we're going to do here is look at T1 plus T2 plus T3 all the way up to T10 on the left hand side. That's T10 plus 100D on the left hand side is equal to term 11 plus term 12 plus all the way up to term 20. So on the left hand side we're going to add the first 10 terms and add our answer to 100 times our common difference, and then we want to see is that equal to term 11 plus term 12 up to term 20. So the first 10 terms here is just going to be S10. We're going to add up our first 10 terms. This is 100 times D, which is going to be 100 times log A. Remember, D here from our previous section is just log A. Now on the right hand side we've got terms 11 up to terms 20. If we add up the first 20 terms and subtract what we get when we add the first 10 terms, that'll give us what we get when we add up terms 11, 12, 13, 14 and so on up to term 20. So add up the first 20, subtract what you would get if you added up the first 10, and that'll give us this lot here. So let's do all of this then. So on the left hand side then we've got S10. So S10 is going to be, using the formula that we used earlier, 10 over 2 times twice the first term, which is log A, plus n minus 1, 10 minus 1, which is 9, times our common difference, which is log A. So that's the formula for the sum of the first n terms. On the right hand side we've got the sum of the first 20 terms, so that's going to be 20 over I just remembered here on the left hand side we've also got to add 100 log A. We have our this is the sum of the first 10 terms, and this is our plus 100 log A here. Okay, so on the right hand side then we've got the same thing again, but this time we have 20 over 2. We want to add up the first 20 terms, twice log A again, plus n minus 1, 20 minus 1, which is 19 log A. So that's the sum of our first 20 terms. We want to subtract the first 10 terms added. So it's really this bit here again, if you like. So it's going to be 10 over 2 twice log A plus 9 log A. So I'm running out of room here. So it's basically this part here again. Now let's do all of this out and see what we get. So on the left hand side we get 5 times 2 log A plus 9 log A is 11 log A, and then we've got plus 100 log A here. On the right hand side we've got 10 times 2 log A plus 19 log A is 21 log A, minus 10 over 2, which is 5, and then we've got 2 log A plus 9 log A, which is 11 log A. Let's do all of this again. So here we've got 55 log A plus 100 log A. Here we've got 210 log A minus 55 log A. So that gives us 55 plus 100 log A, which is 155 log A on the left hand side. And on the right hand side we've got to subtract 55 from 210 log A, so we will get 5 and 1 log A. So our left hand side and right hand sides are both equal, which is exactly what we had to prove. Our left hand side is equal to our right hand side. And that's it for that particular question.